All right, we're going to try a different way of recording this today and see if, well, yeah, I mean, the Collaborate works fine, but it can take like 2 days to process, which isn't as helpful. So I got another online option that allows me to upload to YouTube. As long as YouTube isn't having an issue processing, we might find a better option here. So what's going on with you today? Ugh, was it an experience? I still have not been out of my house. Okay. Didn't freak you out at all, huh? You were good. Okay. Little bit more ballsy than me there, Austin. I did do that. I do force myself to go for a walk pretty much every day, about a half an hour or longer. Get at least a mile in. All right. Hey Ben. I think you got a loud TV or something going on there. There you go. Yeah. 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 Could have been like Spotify or something on in the background too. I don't know. But I know my Pandora is on my television just to kind of keep me company in these days. Oh, okay. That's good. That's on. All right, guys. Are you here to ask questions for the test? Okay. Yeah. So that would be what, like numbers 7 and 8 on the review? Yeah. Okay. All right. Let's do. All right. Can you see the image mate then? Can you see the paper? Okay. Did you have a specific, Ben? Did you want me to do your 7, 8, 9? Did you just want me to do um, in general? Okay. Okay. So from the chapter 3 review, I'm going to look at problem number 7, which says I've got two polynomials, P and D. Use either synthetic or long division to divide P of X divided by D of X. So if we do P of X over D of X for what I have on this one, I've got a 4x squared minus 3x minus 17 And that's being divided by 2x minus 1. So, can you use synthetic division here? How? It does only have 1 degree, but you would have to change that factor. You would have to change this to x minus 1/2. Yep, because if we're going to use synthetic, then this should be a 1x here. And because it's a 2x, I could do it, but and then I'm dealing with synthetic division using 1/2, which some people like, some people don't. I guess if this isn't perfect, if this is not a perfect x minus c, I just always go for long division. And since that's what you asked to see, I'm going to go for long division. So then we've got a 4x squared minus 3x minus 17. Let me get my other pen out here so that I've got some color. Okay, so 2x times what would get me a 4x squared? So I need a 2x there. Multiply back. 2x times 2x is 4x squared. 2x times a negative 1 is a minus 2x. Subtraction means I'm going to change both of those signs. And that's going to give me a negative x minus 17. Now, 2x times what would get me a negative x? Just a negative 1/2, no x on there. Multiplying back, I get a negative x. Negative 1/2 times a negative 1 is a plus 1/2. Subtract. Negative 17 minus a half more is minus 17.5. So my answer here is 2x minus 1/2 plus my remainder, which is a minus 17.5 over 2x minus 1. Oh, when you multiply back? Yep. Yeah, and that's a holdover from like long division that you did in grade school. Because it's always multiply back and then subtract. Now, the only thing I would say is that you can sometimes in the program have an issue with this guy. They don't like that fraction on top of a fraction idea. So this would be 35 over 2. Which switches this to 2x minus 1/2 minus 35 over 2 times 2x minus 1. Okay. Okay. Somebody clicked and put something in the chat. You don't. Oh, okay. What'd you put in there? Okay. Yep. Okay. What kind of function would this be? Okay. Which means the shape would be? Yep. So we've got a parabola here. So what they're getting at is from the first section, which is the standard form of a parabola, where f of x is equal to a x minus h squared plus k, where hk is the vertex. Keeping in mind that for a parabola, the vertex is going to be either a maximum or a minimum, right? So I've got f of x, and I'm going to rewrite this as a negative 1/2 x squared minus x plus 7. Yep. No. We've got to find hk, which means we've got to put this mess into standard form. So to do that, I'm going to factor the 1/2, the negative 1/2 out of the first two terms. You okay with that? Now, with this part, I'm going to complete the square. Because I've got to get this to x minus h squared. So that's going to be a negative 1/2 x squared plus 2x plus 1 plus 7. But now I have to take away what I just added in. I added in a negative 1/2 times 1. So I have to add in a positive 1/2. Okay. I added a 1 in, right? But it's being multiplied by a negative 1/2. So I need the opposite of that here. So I need the opposite of a negative 1/2 times 1. Okay. So that's going to give me a negative 1/2. And then I'm going to have an x plus 1 squared plus 7/2. Or 7.5, not 7/2. This tells me that my a would be a negative 1/2, my h would be a negative 1, and my k would be at 7.5. You were right that this would be a max, and that maximum would occur at hk, or negative 1, 7.5. You're welcome. Okay. What else we got, gentlemen? Okay. Okay. That's the exact one I have. Yeah. All right. So I've got x to the fourth plus 32x squared plus 256. Okay. So what do you see there? You could do like a u substitution. If you let w equal x squared, then you have w squared plus 32w plus 256. But I don't know how much that helps. Yeah. But that is probably telling you something about 256. It is. And in order for this to work, yeah, in order for this to work, it has to be a perfect square of half of that middle term. Nope, what's half of 32? Yep. So that means that this is x squared plus 16 squared. You cannot. If it were x squared minus 16, we'd have some traction. But this is an x squared plus 16. Perfect. So this would be x squared plus 16 times x squared plus 16. X squared plus 16 would be an x plus 4i, x minus 4i. So this one would also be an x plus 4i, x minus 4i. That's now that each of these is to the first power, it's factored all the way. Easy peasy. Sort of. Yeah. Yep. Only I think in the homework it just asks you for the one and then it asks you the multiplicity. Yep. Yep. Yes, that would be correct. Yes. Okay, so P has a degree of 2. Zeros. It's square root, right? Okay. Okay. And they want you to find P of X. Okay. So what does degree 2 tell you? Well, yeah, but we're not going to go quite yet. Okay. So if we've got degree 2, that means we have 2 zeros. Each of those zeros would be a factor. So P of X has to equal X minus 1 plus I root 3 times X minus 1 minus I root 3. No, factors are always X minus. These are just a little bit longer than what you're used to. Okay, so this becomes, now I'm going to distribute that negative, and we get X minus 1 minus I root 3. And then we get an X minus 1 minus minus is plus I root 3. Now, I tend to look at these a little bit differently than some people, probably because I had to do so many of them in my lifetime. But you can now just go ahead and FOIL, right? X times X is X squared, and just do the taking each one in turn and adding them together. And that should get you to the correct answer. It's a little tedious, it's a little messy, but if you're careful, you can get there. I have a tendency to look at it slightly differently. I'm going to group this X minus 1 because it's in both of my sets of parentheses. And I'm going to call that A. Do you see how this is a minus I root 3? And this one is a plus I root 3? Do you see how this gives me now an A minus B and an A plus B? And that's going to be the difference of 2 squareds. So I can think of this as X minus 1 squared minus I square root 3 squared. Now X minus 1, when I square it, is X squared minus 2X plus 1 minus, from that guy, when I square an I squared, or when I square an I, I'm going to get a what? And when I square a square root of 3, so if you can see the patterning, it goes a little bit faster, at least for me. Good? You got it, Ben. With real coefficients? All right, what do you got on number 16 there, Ben? Oh. Okay. You're being asked to factor it. So given that you've got an x cubed, what's your strategy for factoring? Yeah. What was that, Austin? Yep, we're going to factor by grouping. I'm going to look at those two, and then I'm going to look at these two. And if you look at those first two terms, what can you pull out of x cubed minus 5x squared? X minus 5. And then 9x minus 45, you can pull out a, and you're left with x minus 5. Oh, froze, didn't it? Okay, hold up. I got to get out of it, and then I've got to come back. Then I got to go over here. Is it good? Can you see? Yeah. Okay. All right, so now I've got an x minus 5 in both, so I can pull that out front, leaving me an x squared plus 9. Now, what were the instructions? Because I want to make sure I'm clear. Okay. So is this a linear factor? And is this an irreducible quadratic factor? It means I can't factor it anymore with real numbers. Now, for real numbers, this is that same thing you got caught up on before. Yeah, if this was a minus, you could, but because it's a plus 9, you cannot. This is all the further you can go. X squared plus, you cannot go any further with real numbers. So that would be it for part A. Part B says to factor completely into linear factors with complex coefficients. So the x minus 5 would stay, but now x squared plus 9 could be factored into x and x. You got it. Okay. All right, Austin, did you have anything else? Yeah. Okay. Okay. This was like, I want to say this was like number 16. Okay, yeah. All right, so rational zeros, irrational zeros, it says whenever appropriate, use the rational zeros theorem, upper and lower bounds, Descartes' rule of sign, quadratic formula, or any other factoring techniques you know. So you're wide open to use everything from the chapter here, right? So I guess I started this guy with Descartes' rule of signs. Descartes' rule of sign is again where you looked at how many positive solutions there would be, how many negative solutions there would be, and how many imaginary solutions or complex. And to do that, we used the rule of signs, which says if you go from 12x to the fourth being positive to a negative 11x cubed, that's one sign change. Then it stays negative, then it switches to positive. So as is, we have two possible positive solutions, or it could drop by 0, giving us 0 positive solutions. If I look in at p of negative x, that would not change the 12x to the fourth. It would change the sign on 11x to the third. It would not change 18x squared, but it would change the 5x. This is still going to give me, oh, now I've only got one sign change. So I could have one negative solution or I could have 0. Imaginary solutions have to come in pairs, just like what we were doing the 3i and the minus 3i. So I can't have one imaginary solution. I could have 0, 2, or 4. So my imaginary solutions could be 4, 2, or 0, depending upon the combination. Now, what that means is, since my positive and negative solutions do not add up to my 4 here, I'm missing something. So my suggestion is you look first at the 4 terms here, and is there anything you could factor out, I'm sorry, in the original? No, in the whole thing. Yeah. And if x is a factor, then I know that x could be 0. Oh, thank you. Okay. And that 0 is not going to be positive, it's not going to be negative, and it's certainly not imaginary. So, and that's my sort of missing guy there. Now, I'm just going to look at this for the remainder because I've already factored that x out. So then when I do my p over q for all possible rational solutions. Oh, God bless. This is going to be a little tedious, guys. Okay. So we can have a plus or minus 1, and we can have a plus or minus 5. We can have a plus or minus 1 over 2, because 2 is a factor of that lead, and we can have a plus or minus 5 over 2. We can have a plus or minus 1 over 3. We can have a plus or minus 5 over 3. We can have a plus or minus 1 over 4. We could have a plus or minus 5 over 4. We could have a plus or minus 1 over 6. We could have a plus or minus 5 over 6. We could have a plus or minus 1 over 12. And we could have a plus or minus 5 over 12. And I think that hits all of them. Holy. Okay. Now, I would like to use synthetic division. And I'm going to try a 1. Would you prefer to try a positive 1 or a negative 1? Positive 1. Okay. It really doesn't matter. We're shooting in the dark. We're looking for 2 positive solutions and 1 negative solution. So if we do a positive 1, we've got a 12, a negative 11, a negative 18, and a 5. So the 12 comes down. 1 times 12 is 12. That's going to give me a 1. 1 times 1 is 1. The negative 17. And this gives me a remainder of negative 12. So it's not a 1. Okay? I'm going to try a negative 1. Because I want to exhaust all the easy numbers first. 12, negative 11, negative 18, and a 5. So 12, that's going to be a negative 12. That's going to be a negative 23, which when I multiply is 23. That's going to be a 5, and that's going to be a negative 5 and a 0. Okay? So we know, yeah, so that means we've got our negative number. Right? Now, froze again. Are we back? Okay. All right, now, what's key here is that what's remaining is 12x squared minus 23x plus 5. Froze again, didn't it? Now that it's just an x squared, you bet. I'm going to go with what I know best. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac. So 23 squared minus 4 times 12 times 5. So that's the square root of 289, which I think is 17. Over 24. So that's going to be 23 plus or minus 17 over 24. If I add, I'm going to get 40 over 24, which is 5/3. And if I subtract, I'm going to get 6 over 24, which is 1/4. And that's my 2 positive solutions. So my rational zeros, x could be a -1. Don't forget the 0 we pulled out from the beginning, 1/4 and 5/3. All of these are rational. There wouldn't be, right? Because how many solutions? Yeah, we've reached our maximum number of solutions for this problem. Okay. Good, good, good. All right, gentlemen, 20 minutes. What more you got for me? Okay. That's all right. Okay, so if you don't have anything else, that's absolutely fine. What is this? Oh, no, that's going to be goofy. So what we can do then is we can just call it if you're all right with that. And yeah, just to sort of be respectful of everybody's time and what more you might have to do today. I don't know. But test is due tomorrow at 11:59. I didn't realize that the review still had the old due time date on it. So I updated the review to be 11:58 tomorrow night. So you could work on both hand in hand if you wanted to. I want to say it's just 12. It's like less than 15 for sure. Okay. But I still wouldn't leave it because some of them are long. And you can pop in and out of it. Just know that. So like you could go in and do 3 problems today and then go back to it and finish it up tomorrow. That's no. I mean, there's a deadline, but there's not a time limit. Okay. All right. If you need anything, let me know. I am here. Okay. Thank you, gentlemen. You have a good night, good weekend. All right. Bye-bye.